Welcome back. In this next video, we're going to learn another method we could use to create new variables from existing variables. So with this first one, we were just combining quantitative variables together to create more quantitative variables. In this video that we're going to look at today, we're actually going to use a technique called binning. And this is going to allow us to create a categorical variable, an ordinal categorical variable from a quantitative variable. So it's a super useful way to look at data from a new perspective, especially if you have a quantitative variable that just isn't really strong at all. So this might be a good option for those basement square feet variables that clearly don't have a strong relationship, or even some that have that moderate relationship, if we might be able to make that stronger. We can also use these binning techniques to discretize variables. So this is where we kind of create an ordinal numerical variable. And this helps smooth out skewness and reduce outlier influence. So we can create a categorical variable using this technique, or we could create a discrete quantitative variable using this technique as well. But one thing that is very important is these if statements that you're about to learn, these singular if statements and these nested if statements, they're also called if-else statements, are so widely used, not just in Excel, in many other analytical software applications. It's very important to learn, and also it's really cool to see kind of the logic that is imparted behind it. So to get started, we're going to create another new worksheet, and we want this worksheet to be one to the right of this aggregation worksheet that we did in the first lecture video or lab video. So I'm going to stay clicked in this worksheet, and I'll come over here and click my plus sign. In this one, we're going to rename bin create lab, because we're going to be using this binning technique to create some new features. Okay, now the next step is we have to select the data that we need for this worksheet. So from my cleaned data, I'm going to select house ID, and I'm going to select fireplace. Oops. Select house ID, and I'm going to select fireplaces. So just clicking on column letter A, hold down Control or Command, click on column letter D, and then Control C to copy, and then we'll paste here. Now, anytime we're combining data that's from different worksheets, we have to make sure that first the data is the same dimensions, that it has the exact same number of observations, and that they're all sorted in the same way. So if your data in these worksheets is not sorted by house ID, you need to make sure that that is the case before you start copying data, to make sure that the proper observations match up with the proper house. So our worksheet should by default be sorted that way, but it's very important for you to check each time. Okay, so we've selected those, and then the other variables that I need are going to come from this aggregation lab. So if you haven't done this aggregation lab, you're going to have to go do it before you do the second piece. The next thing is we're going to take our total inside area. So this was our best one. We probably wouldn't try to bin this when we have such a strong relationship. However, for the purposes of just showing you the techniques, we'll take it with us. So we'll take total inside area. I'm going to click on column letter G from my Ag Create Lab worksheet, hold down Control or Command, and then select sale price. I'm just confirming that this data is sorted by house ID from 1 all the way down to 1,521. Control C to copy those, and then we'll paste them here right next to the data. Okay, let me see. Okay, this did just store the values when I pasted. That is one thing that you want to make sure, is that if you have formulas that are creating this variable, when you paste it over here, you want to make sure those formulas are not present. It just might cause you some issues. It could easily alter your data if you accidentally click something wrong. So if it doesn't paste without the formula by default, then you can, when you go to paste, just right click and say paste as values. Okay, we've learned how to do that in some previous lectures. Okay, so now that I have my data here, I'm going to be creating 2 new columns. Okay, I need to create one new column between fireplaces and inside area, and then I'm going to create another column between inside area and sale price. So because I want one column to be inserted to the right of column C, I'm going to highlight column C. I'll come up here to my cell tool ribbon and press insert. You can also right click and press insert. And again here, since I want one column to the right of column E, I'm going to select column E, and then alternatively you could right click and press insert. So 2 different ways you can insert those columns. All right, and I like how this stayed color-coded blue because we're going to create a binary fireplace variable here, and we're going to create a categorical variable for area over here. So we're just going to call this fireplace binary. And all we're going to be doing here is saying, all right, does this house have a fireplace or not? I don't care how many fireplaces it has, just does it have a fireplace or does it not? Okay, and the other one that we're going to create is going to be called, I believe, inside area category. Yeah, inside area size category. I think is what I have it called in the lab slides. Inside area lab category. Okay, so we're going to start with the binary one because this will just get us introduced to what an if statement is and kind of what it's doing. We talked through it in the lecture slides, but these things can be a bit challenging if you've never used them before. So just pay careful attention. You really have to make sure that every comma is in the right place, that you're meeting every argument. Otherwise, you're going to get error messages and it's not going to work for you. Okay, so all we're doing is I'm going to talk you through what this formula is saying as we apply it. So start with the equal sign. Every formula, every function in Excel starts with an equal sign. Starts with equal and then type the word if. Okay, so but the tooltip says it checks whether a condition is met and returns one value if it's true and another value if it's false. Okay, so if we open up that parentheses, we'll see the arguments. The first argument is a logical test. Okay, this logical test has to have an equal sign, a greater than sign, a less than sign, some sort of inequality sign to evaluate the logic. Okay, so what we're going to say is if the fireplace variable, the original one, is equal to 0, okay, then, okay, I have to put my comma to get to the value of true. Now this is where we put the value if it's true. If you're recoding it as a numerical value, you just put the number. Don't put it in quotations. But if you're recoding it as a categorical value, you have to put it in quotations. For this variable, I'm just going to code it in 1s and 0s, and we can update the labels on the backside so you see what it looks like to use these if statements to code a quantitative variable and what it looks like to code a categorical variable in the next one. So we're saying if fireplaces equals 0, then that means 0 or no. In this instance, 0 means no fireplaces. Okay, so that's the value of true. Now we need another comma to get to the value of false. So since this is a binary operator, we're just going to use 1s and 0s. This is that 0, 1, yes, no, true, false, right, wrong. There's only 2 options, which is why it's called a binary variable. So if B2, if fireplaces equals 0, then we're going to give it the value of 0, indicating there's no fireplace. But if it's true, if it has 1 fireplace, 2 fireplaces, 3 fireplaces, 4 fireplaces, we'll give it a value of 1. And that 1 just signifies that, yes, this house has a fireplace. That's it. It's just as simple as that. So we see that because this house had 1 fireplace, it returned a 1. Now we can use that quick fill again. Come to this cell. Come to the very right corner where that green square is, hover over it and double click to fill that. So we can see this house that had no fireplaces got a value of 2. This house that had 2 fireplaces still only got a value of 1 because that was our operator. If it equals 0, give it 0. If it equals anything other than 0, give it a 1, indicating that that house has at least one fireplace. Okay, and that's all. That's all there is to it. We'll create a table in a minute so we can visualize the relationship between sale price, but that is, it's as simple as that. Now, when we do this over here, it's going to be a bit more complex. We're going to have to use a nested if statement because we have more than just one thing to categorize. We have more than just 2 outcomes. When you have more than just 2 outcomes, you have to nest these if statements inside of each other. And this is what we call an if-else statement. If it meets this criteria, give it this. Else, evaluate this criteria. If it meets that criteria, assign it this. Else, and just keep on going and going. All right, so for this one, we're going to categorize the size. And there's lots of different ways you can do this. You can make sure that each of the categories have an equal width. You can make sure that each of the categories has an equal frequency, or you can just impart some logic and recode them, according to a user-defined method. So as always, we're going to start with an equal sign and then start your if statement. Now we'll open the parentheses and we have to give it our first logical test. Okay, now we used equal signs for our logical test in our binary variable, but in this one we're going to use less than. So we're going to say if the total inside square feet, that's cell D2 right here, is less than 1,500. So if the total square footage of the house is less than 1,500 square feet, we're going to call that, we got to get our comma to get to our value of true. So if that's true, if the house has less than 1,500 square feet in all the finished and unfinished spaces in the house, then we're going to say that that house gets an extra small category size. Okay, that's like a lot of apartments are 1,000 square feet, 1,500 square feet. Okay, and then we'll close up that quotation. And what you notice between this one versus the other one, when we were coding with numbers, we didn't have to put them in quotations. We just put 0 and 1. But when we're using categorical labels, we have to make sure those categorical labels are wrapped in quotations. Otherwise, you'll get an error message and your function won't execute. So we're saying, all right, if the square footage is less than 1,500, give it that extra small label. Now we have to go to the value of false. Well, we're going to be categorizing houses as small, as average, as large, and as extra large. So we still have 4 categories to go. We can't use one if statement. This is where we have to start nesting them to account for every category that we want to create. So we'll start now where we would normally put one single value if false. This is where we're going to nest that next if statement. We'll start with if. We have to open the parentheses to open up that function, and we're going to select D2 again. Okay, we're always going to be evaluating the same cell in the same row. So if it's less than 2,250, okay, we're going to say that that gets a small label. Again, make sure it's in quotations. Now we still have the average size, we still have large, and we still have extra large, so we're not done. We have to keep nesting. So if the value is false, we have to give it another if statement. Open, again, always evaluating the same cell in the same row. If D2 is less than 3,000, we're going to give that the value of average. Again, always in quotations. Now we have 2 more categories to go. We have that large category and the extra large category. So we only actually need one more if statement because we have 2 categories left. Just like with our binary variable where we only had 2 categories, we're down to our last 2. So we only need one more if statement to create those last 2 categories. So for value of false, we're going to if, open parentheses, D2 is less than 3,750. We're going to say that that's a large size. Okay. Okay, now we're down to our last value of false. There's only one other value that we're going to be using. That's extra large. There's no more categories that we're going to be creating past extra large. So we don't need another nested if statement. We can just give it that last value if false. So it doesn't meet the criteria for extra small, if it doesn't meet the criteria for small, if it doesn't meet the criteria for average, if it doesn't meet the criteria for large, then by default it has to be that extra large category. So this last value of false is just going to be extra large. And then we'll close that quotation, and we're going to have to close it up 1 for every open parentheses. The cool thing about Excel is it does color code things for you. So my first one here, this green parentheses is closed with this green one. This purple parentheses right here is closed with this purple one. This red parentheses here is closed with this red one. And then once we get to the black parentheses, that means we've closed up all of these operations within this nested if statement. Okay, so let's turn the value. Okay, if you get a value, you're probably pretty good. It doesn't indicate that there's an error. Okay, we'll fill that function. Okay, and then just scroll down. If you have anything that doesn't look right, you need to go check your function. But if everything looks like it's in the right place, then you're good to go. Okay. And we'll be able to tell also when we create this pivot table. So just to kind of reiterate how this works. So if we first assess this criteria, okay, if it meets this criteria, it's not going to assess that same cell for the next one. So right here we have extra small. Since this was less than 1500, it's already gotten this label. So it's not going to go back and override it with small because this 1,396 is also less than this. It's also less than this. It's also less than this. So if it actually meets a criteria that's true, then it stops there. It won't go back and reevaluate that and override it with any of these other labels. And that's part of that nesting logic. So once the criteria is satisfied, it doesn't get reevaluated, and that's why everything ends up in the proper place. Okay, so one last little point that I want to make is when you're doing this, okay, you have to make sure that every parentheses is in the right place, every comma is in the right place, every quotation's in the right place, all of it. It has to be exact. If any of these things are out of place or missing, it's not going to execute your function. Okay, another thing, okay, we're always evaluating the same cell in a single row. So we've always referenced D2 here. And then also when we're using numerical values, they do not need to be wrapped in quotations, but when we're using categorical labels, they must be wrapped in quotations. Okay. So now we're just going to check to see, is there a relationship, or would we suspect there to be a relationship? Now, because total area already had a pretty significant relationship with sale price, I'd expect there to see a relationship here also, but let's just confirm that. So we're going to do this by creating a pivot table. So we've done pivot tables before. If you go to your insert ribbon, it's this first option right here, but we're going to add some additional information in ways that we haven't done before in the past. So click on that pivot table, okay, and again, this first argument is the table range. So I'm going to select all of my columns, okay, and I'm just going to select the cells. If you're on a Windows or a Mac, you can just select the columns like this. If you're on a different operating system, Chromebook or any of that, you're going to have to select just the actual cells that have data. So I only really need to include my binary variable through sale price. So I'm going to click in C1, and I'm going to use Control Shift and arrow over to the right to select those labels, and then arrow down to select to the bottom of the page. Okay, using those hotkeys. You can also click and drag. If you're on a Windows or a Mac, you can just select the letters up at the top, whatever's easiest for you. Now, we're going to paste this table in our existing worksheet. It was probably in a good location already, but we'll just click on one cell to the right of the data towards the top of the worksheet, like we've done in all the previous labs and homework assignments that we've done so far. Then press OK. All right, so we're first going to do let's do our inside area category variable. This should say size, not lab category, by the way, but that's okay. We'll drag this down to the rows. That's going to give us our categorical labels. Okay, we'll drag it again to the values. That's going to let us know how many observations are in every category. Okay, and then the other thing that I'm going to do is I'm going to add sale price here. Okay, when we add sale price, by default, it's going to sum that value. We don't want it to sum, we want it to average. We want to see what's the average sale price for each of these houses, house sizes. So if we go here to our pivot table fields box, click on this drop down and change value field settings to from sum to average. Okay, so now we see average sale prices is what we want. If your pivot table fields menu disappears over here, you should be able to click back in the table and it will reappear. If not, you'll need to come to this pivot table analyze tab and click on this fields list button. So if it's disappeared, that won't be enabled. You'll just re-click on it and it will re-enable that. Okay. Now the next thing I'm going to do is just copy and paste this table over to the side so I can clean it up. So I'll highlight the table. Oh, I want to do one thing before I do that. This is an ordinal variable now, right? I need to make sure that they're in order. So I'm going to take my extra small category and go to the edge until I get that multi-directional icon, and I'll drag it to the top. Okay, I know extra large has got to go to the bottom. Get that, there it is. Okay, I know small has got to go between extra small and small. Okay, so there's my order. Now I'll copy my table and clean it up. Copy, come over here to the right, and we'll paste as values. Okay. I'll update these. This is going to be my total area size. This is the frequency. This is average sale price. It's fine. You can leave that here. Okay. Next thing, I'll add just a simple title. It doesn't have to be. Okay. This is inside area size category assessment. Just something simple. Okay, we'll give it those borders and shading. Add that formatting to clean it up, make it look nice and neat. Can format these sale price values as dollars. If we want to center these items within the cells, we can do that. And there we go. Okay, now what we're looking for here is we want to, hopefully, ideally, we'll see that as we increase the overall size of the home, that the sale price increases, right? And I believe that's what we see. You know, for these extra small homes, their average sale price is about $100,000. For the small ones, about $130,000, $131,000 on average. For the average home, that's about $180,000, which is consistent with our overall average down here, right, of all the homes. Our large homes are a little over $250,000 on average, and our extra large homes are around $350,000 on average. So that makes sense, right? As we increase the size of a home, the average sale price should also increase. Now, I don't know if I would use this variable in my final model because, again, we've already determined in the previous part in our aggregation lab that this variable, when we created it, had a very strong relationship with sale price from a quantitative perspective. So we'd probably leave it like that. But if you do have other quantitative variables that have that moderate relationship and you want to try to see if creating categorical variable out of it or discretizing that variable would improve the relationship, then this is a good option to try. Okay, we'll just switch this to evaluate fireplace now. We can drag fireplace down here. We'll remove the size variable, and then now we have our table for fireplace. So I'm actually just going to copy the first few parts of this table and reuse the information. Okay, So here we would just copy these things and we'll paste them as values here. And then we know that when this fireplace variable got a 0, that means it had no fireplace. And when it got a value of 1, that just means it had at least one fireplace. So sometimes it had 2 fireplaces, sometimes it had 3 fireplaces, but we know that it at least had 1. And that's a really good kind of even distribution for us to be able to tell differences. This is fireplace binary category assessment. Okay, and so what this tells us is that when a house doesn't have a fireplace, on average, it sells for like $148,000. When it does have at least one fireplace, the average sale price increases almost by $75,000. That's pretty significant. So this might be a good option to use in that final model, especially since some of those when the houses that have 2 fireplaces or 3 fireplaces or 4 fireplaces are not very abundant. They're really low frequency categories. So this would be an option to be able to really take advantage of that variable, add some useful information to your model in a pretty simple form. So that's all for this lecture or this lab. Now again, you're going to be applying these same techniques to your homework data. It'll very explicitly tell you what you're supposed to do, but in any case you'll be using aggregation methods and you'll be using these binning methods, these if statements and nested if statements to create these new variables.